Yes, class. Am I audible to all of you? Alia, Austin, Fia, Humam,
Yes, ma'am.
Shahid, Shavez, you connected? Okay, let's start with the class. So yesterday we had stopped at this point where we were calculating. We had calculated the average value of AC AC as well as EMF for half cycle and full cycle. Half cycle we obtained the value as 2 by pi. This one, 2 I naught by pi. And same thing, 2 by pi E naught. But we had it 0 for the complete full cycle. Now, one thing that was left, which I wanted to discuss, was RMS value of current or EMF you will also get. See, RMS value means what? Whenever we have RMS value, R means root, then mean, M means mean, and square stands for, S stands for square. So this is root, mean, square, right? Now see, this is root first, mean second, then third, square. But when you're actually solving it, when you're actually finding out the value of RMS, you reverse it. First you put down the square of the quantity. We'll calculate the square. Then second step will be calculating the mean. That is, how will you calculate the mean for such values? You will integrate it from 0 to t over the entire time. This is how we find out the mean total value of current by the time. And then at the last, we put the root. This is the steps that has to be followed when we're talking about the RMS value of current. RMS value of current means effective current or the virtual current. All right, class. So root, mean, square is the order, but the actual sequence is square, mean, and then root. This is the value how RMS values are calculated. Now, see class, we'll solve this later, root and everything. First, let us just find out the simple meaning of I square dt 0 to t. Because if I will be solving within this only, no, it will become very confusing when the roots are present, and then I'll divide it by t and put an under root. All right, now see, what was I square? This is I naught square sine square omega t dt, integrating it from 0 to t. This is the same step, exact same step which we followed in the last class. Now, whenever you have sine square omega t, so integration of it becomes 1 minus cos 2 omega t. Then again, 2 is a constant, so this will come in division form. This is, you have to remember these trigonometric identities, trigonometric values for solving integration. So this is from 0 to t. I naught square, you can take it common. So see, what are we left? Just remember this. How are we solving it? How are we getting it? Sine square omega t is written like this. This is the integration of sine square omega t. Clear class? This is sine square omega t. So, and what is this quantity? Here you are having I square dt. Here you are having I square dt. Basically, we are integrating this part. So now we have kept the value of I here. We have squared it. These are the limits. We have integrated this and have obtained this. Clear? And I square is constant, so we have kept it aside. Fine. This is clear, class. Now see, if I have 1 minus cos 2 omega t dt, I can multiply this and then I can multiply this. So that becomes dt minus cos 2 omega t dt, right? So it means this integration of dt will become t, and integration of this will become, what will this become? Sine 2 omega t divided by 2. Clear? So when you are integrating cos omega t, when we are integrating this, so we are getting again sine theta back in our equation. I square, I naught square by 2, this 2, t minus what is left? Sine 2 omega t divided by 2 omega, values ranging from 0 to capital T. All right, values ranging from 0 to capital T. So I naught square by 2, then T minus 1 by 2 omega, and then this is 2 omega T from 0 to T. Now we can put the value of omega. Remember in the last class also we have put, what is the value of omega? 2 pi by T. So same value will put. This is I naught square by 2. This becomes T minus 1 by 2 omega. This becomes sine 4 pi T. 2 into 2 omega by T, 2 pi by T. 2 into 2 pi by T, that becomes 4 pi by T into T. All this entire value from 0 to capital T, right? From 0 to capital T. Now C class, once this is obtained, when you will put the limits, when you will substitute in the limits, I naught square by 2, this is T 1 by 2 omega C class. First put in capital T. That becomes sine 4 pi only. Capital T and this T will be cancelled. Minus this is sine 0 degree. So 4 pi minus 0 is 0. This is also 0 and this is also 0. So entire answer, this part becomes 0. Fine class. This one part, this will become 0. Now see, so entire this part will be 0. 1 by 2 omega into 0 is also 0. So ultimately we are just left with what we were calculating. We were calculating this part, I squared dt from 0 to t. Which step, Fia? This step.
Yes, ma'am.
This step, Fia.
Yes, ma'am. That step.
See, in this step, we have one step before is this, no? We have put the upper limit. That is sine, see, sine 4 pi by t into small t. First value of upper limit we have put. So capital T and capital T will be cancelled. So we are left with sine 4 pi, which is 0. And second is 4 pi by t into 0. That is sine 0. So that is also 0. So 0 minus 0 is also 0, and 0 multiplied to 1 by 2 pi is also 0. So this entire bracket will become 0, right? This part will become 0. So what are we left with? I naught square t by 2. This is the value of this part. But what was our mean square formula? Remember in the starting with which we have started the class, I square dt from 0 to t divided by t under root. It means this is I naught square t by 2t under root. T get cancelled. So we are left with this is IRMS equal to I naught divided by root 2. This is a very, very important formula which you have to remember. Similar to this, you have to remember ERMS. ERMS is E naught divided by root 2. This is also very important. These formulas are very important for your examination and for the numericals. If I naught is asked and you know IRMS, so that will become root 2 IRMS. This is also used a lot in calculations. Similarly, E naught will be root 2 times the ERMS value. Like this, you will be having all the values. Note it down, whichever step you're not able to understand, let me know. Remember, in many books, you will find this written as I effective is I naught by root 2, or I virtual is equal to I naught by root 2. All means the same, that is RMS value itself. Note it down. See class, let us discuss this question because these types of questions will come a lot. It is saying E is equal to 140 sine 300t, right? You have to find out peak value of the voltage, its RMS value, its frequency of supply. It's a very, very easy question. It's just that you have to compare it with the standardized equation. What is the value of, what is our standardized equation? See the equation that is given to 100t. This is the equation 140 sine 300t. What is our standardized equation, which we have studied yesterday? E is equal to E naught sine omega t. Now can you relate? E is equal to E naught sine omega t. E naught was what? E naught was the peak value. Yes, right. This was the peak value. Peak value, amplitude, maximum value, any name you can give. So you just have to compare. In place of E naught, what is written? 140. So what should be your answer? Directly without any calculations. First answer, EMF will be, E naught will be 140 volt. Second part is asking RMS value. See class, we have studied E naught is 140 volt. ERMS is just now you have derived this relation. This relation is very important. E naught by root 2. What do you need? You need this. You only. This becomes 140 divided by root 2. Let's write the approximate value of root 2 as well, 1.4. That is 100 volt, right? Then it is saying angular frequency, frequency of supply. Look here. If it is saying frequency, how much? Yes. Can anyone tell me? 300. Very good. See, this is the angular frequency. But class, there's a slight problem. Our question is just frequency. So if we know that if we know omega, we'll be able to calculate. Omega is 2 pi into frequency. So frequency is actually omega by 2 pi. If this is omega by 2 pi, if this is omega by 2 pi, omega is 300. So linear frequency will become 300 by 2 pi. So frequency is 150 by pi hertz. This is your answer. 150 by pi hertz. That's how you have to solve all the questions. Once we are thorough with the phasors, then I'll discuss. Note down the question and start Yes, class. Now see, next topic is phasors. Phasor is basically what? It's a rotating vector that represents a sinusoidally varying quantity. This means what is the variable sinusoidal quantity that we are having? It's actually the EMF's value, correct? Value of EMF and value of the current. These are only variable, right? So phasor is basically represents it. You will have EMF, it will be in the form of current, right? It will be in the form of graph. Then you will be having values of current. Current, EMF, both have to be represented on the same quantity. Understood, class? See, current is present, it is varying sinusoidally. EMF is present, it is varying sinusoidally. Some values of current are ahead of EMF, some values are behind it. So how will you represent it? So how will you represent these values? So a phasor is basically a rotating vector that represents a sinusoidally varying quantity. All right, just a second. Okay, yes, class. So phasor is a rotating vector that represents a sinusoidally varying quantity. Now you have phasor diagrams as well, that is in a rotating frame, like the form of a pie chart. You have to represent current and voltage. See, this will be clear. This is a phasor. This is like a phasor. Suppose if I give you the value of EMF. This is the value of EMF. All right. Suppose in this same phasor, I'm representing the value of current. This is the value of current, right? Now, between these EMF and current, the angle that is given is phi. So these are the phasors. That means these are the rotating vectors. These are the phasors, they are the rotating vectors. All right. Current is variable, EMF is variable. Now this will change. This will again change. Now EMF will be ahead of current, current will be ahead of EMF. This depends on every device. You are having 3 devices in your system. One is circuit having only a resistor, then you have circuit having only inductor, then you have circuit having only capacitor. All right, class, do one thing, note this down, then we'll start the circuits individually. Yes, class. Completed. Yes, class. Completed. Alia, Austin, class, am I audible? Internet issues are going here.
No, completed.
My screen is sharing with all of you. It breaks in between.
No, you can see the screen.
You can see the screen, no? All right. Good, good. Then fine. Because my laptop is also hanging and internet issues are also there today. See, AC circuit containing only resistor. When a resistor is connected with your circuit, you are having a variable value of AC, right? This is changing the value of EMF. So now EMF is E naught sine omega t. You have connected a resistor. Resistor is connected along with the help of circuit, right? So how do we start? What is the voltage? Voltage, that is EMF. This is E naught sine omega t equal to Q. So charge is equal to C. Current is dq over dt. So when you differentiate it, instead of the entire value of the charge that you're getting, when you will differentiate this charge, you will again put it as C epsilon naught sine omega t. Right, class? See, you have the value of the charge with you. When you are differentiating it, so this becomes d over dt C epsilon naught sine omega t. Fine? Now see, again, coming back to the derivation. C epsilon naught sine omega t. When you're having this as constant, I have told you, differentiation of sine omega t will give you omega sine omega t back, right? So if you have omega sine omega t, this becomes omega C epsilon naught sine. Now, pay attention over here. This is what? Cos omega t. This becomes, in this entire sine part, this becomes cos omega t. Cos omega t, right? Now class, if I want to write this epsilon naught will also be, if I want to write cos omega t in terms of theta, how will I write it? Sin 90 minus theta? Have you all heard of sin 90 minus theta? Sin 90 minus theta we will use, yes.
Yes, ma'am.
This becomes sine 90 plus theta. Because if you reverse it, that becomes minus. So this becomes sine pi by 2 plus omega t. All right. So what is the value? I is equal to, my voice is still breaking.
Sometimes.
Just a minute. We'll have I naught screen is sharing.
It is not there.
Screen is not sharing. Just a second. Wait. Please update class.
So you can see.
It's fine, no? See, I'll tell you the rest of the details and capacitance because the network is not working properly. So let us discuss it individually. Just understand it in this way. AC circuit containing only a resistor. You are having a circuit that is having the value of resistor. If a resistor is connected, had it been connected in your DC circuits, had this was connected in your DC circuits, how would you have used it? You have the value of EMF. EMF is variable this times. Why? Because we are talking about alternating current. So if it is variable, if this is varying, this becomes E naught sine omega t. Resistor is connected with the help of wire, right? So E is equal to E naught sine omega t. Simple. If you had the DC circuit, which law would you have been using? You would have used Ohm's law, right? Ohm's law is V is equal to IR, right? That is EMF is equal to IR. So E naught sine omega t is equal to IR. So I naught is equal to E naught by R sine omega t directly. Forget about capacitance, inductance, that we'll do it individually only, then only it will become clear. Now see, I is equal to E naught by R. What is E naught by R? This is I naught sine omega t. That's it, what you have to remember. Let me repeat it because the internet was this is the case of resistor. See, you are having an AC circuit where only a resistor is connected. This is the value of voltage this time. We know the way we use normal simple value of voltage, simple values of EMF, E naught sine omega t. We are using E naught sine omega t in terms of that. So this becomes E naught sine omega t. V is equal to IR. So E is equal to IR. This is all using your Ohm's law. So E, what is the value of E? E is E naught sine omega t. So we have kept the value as E naught sine omega t is equal to IR, right? So from here, value of current is E naught sine omega t by R, and compare it with the main equation, I naught sine omega t. That means what is the value of I naught? I naught is E naught by R in your circuits having only resistors. Now coming to phasors. Always remember the phasors for the circuits having only resistor, they are in the same phase. That is EMF and current both are in the same phase. For example, this is EMF. Then the value of current will also be this with subtending some angle omega t, we do not know, so subtending certain angle. This is phasor diagram. All right, this is how we represent a phasor diagram, and this is the graph. See, you can represent it graphically also. Suppose this is EMF, this is EMF, and this is the value of current. This is the value of current. So here there would be a maximum value I naught, here would be a maximum value, that is E naught. This is the graph. So how do you represent its phasor like this? This is just showing that EMF's magnitude is higher. Both have a starting point. Phases are same. Nobody is leading each other to any quantity. Quickly note it down, class. The internet is already not working well over here. Just note it down. Whatever doubts you are having, I'll take it. Just first copy it down. there. The laptop is also hanging and network issues are also there. Constantly the net is going. So this way you will not be able to understand. This is an important portion. We'll do it next week. Okay, class. You people can start leaving. In the next class, I'll continue all this.
Thank you.